Well, okay, so the first one is problem number 29. There are a number of students that have trouble with this. Number 29. Okay, so let's draw the picture. Okay, it's not it's not perfect, but I'm going to do my best. Okay, that's not good. This is not the does not look like the meet the requirement. That's good. All right, so we have A, and B, and C, okay, and this is a D, I believe that. Okay, A's, these are the AC so that it's a bisect. Oh, still bisect. So that means I needed to draw a little bit longer this side. Okay, so this is the A. Yeah, modify a little bit. So these two angles are same, okay? These two angles are same. It's hard to draw it, meet all the requirements. Okay, so we know that, let's write down, okay, AB equals AC, so still not perfect graph. Okay, AB equals AC, okay? And these on the line AC, and which BD bisects the angle ABC, okay? And the BD equals BC. Okay? BD equals BC. Okay. So look at this picture, okay? So we have, suppose this is a beta, right? This is a beta, right? And AB equals AC implies 2 alpha equals beta. Okay. The next condition, BD equals BC. BD equals BC, and this should be better. Okay, BD equals BC. You know, this is isosceles triangle. Okay. Then one by one. Then you want to determine the angle at the point A. Okay, when you look at this picture, right? And I think the relationship, yeah, because you already have a triangles here, right? The triangle. So alpha plus 2 beta equals 180 degrees. So from here, you can solve for alpha and beta immediately. Okay? Once you solve for alpha and beta, then you can answer the question. Okay? So here, beta, let's do that. Alpha, beta is going to be 2 alpha, 2 alpha equals 180 degrees. So 5 alpha equals 180 degrees. Alpha is going to be 180 degrees divided by 5. I think it's 36 degrees. Okay. So alpha is 36 degrees. Then beta is going to be 2 times 36 degrees. It's going to be 72 degrees. Okay. So beta, yeah. So this is a, yeah, AB, you know, AB equals AC. So anyway, so you already get a beta, right? So the angle at the point A is going to be 180 degrees minus 2 betas, right? Beta and beta, right? These two angles are the same. So because this is an isosceles triangle, and the 2 times 72 degrees, let's figure it out. Okay, it is going to be 180 degrees minus 144 degrees. And let's see what we get. 30, I think it's 36, right? Again. Yeah. So which problem you, Darren? I don't understand your question. So I'm discussing a couple problems here right now, okay? So this is so you draw the picture, the only formula, two important facts you have to know that if a isosceles triangle, then 2 base angles are identical. And another fact you should know is the sum of 3 angles inside triangle must be equal to 100 degrees. So let's go back to, let's go back to this problem again. You know, somebody has questions. So let's see if I'm copying correctly, right? AB equals AC. So that means 2 alpha equals beta. Okay, right? then you BD equals BC. That means those two angles are equal to beta. So you can then you apply. Then you can apply. Yeah, then the sum of the interior angles is 100 degrees. So then you get to these two equations. Just solve it. Okay. Okay. Once you get to alpha, then you can get a beta. Then you. All right. So why do I need to minus 140 degrees? You see, I'm applying the formula here. You see, this is A, that's a B and C. Okay? If this is a beta and this is a beta, how can I get another one? The sum of the sum of the three. Yeah, you can also do the difference. Yeah, you know, okay, beta minus alpha is okay. There are many ways to do it because beta is the exterior angle. If this is an X, right? So beta is going to be alpha plus X. So X is going to be X is going to be alpha. Okay, 160. That's just many ways to do. Okay. So let's yeah. Then X is just beta minus alpha. It's the same. Another number 26. I'm not going to talk about number 26 because this is if you draw the picture correctly, so you get a square. So you just find the edge length of each side, then you solve the problem. Okay. My next problem I want to discuss is next problem I want to discuss is the following picture. It's number 3 here. You have a rectangle, you know, A and the B and the C and the D, and then you draw the 2 and the F and the G, right? And that is E. So you write down the given information. So A, B is going to be 6, so mark it. And the BC is going to be 3, right? F, G are on the side CD. Was segment DF is going to be 1, right? And the segment GC is going to be 2, right? So the line AF and the BG intersects at the point E, okay? So what is the area of the triangle AEB? What is the area of the triangle AEB? So the area of triangle AEB, you just need to find the height, right? As long as you can find the height, you can solve the problem. When you draw the height, then you just need to find the height of the other part. Okay, so this is there are many similar triangles here. Okay, use the similarity. So if you know, let's call the X. If you know this X, then H is going to be X plus 3, right? So yeah, you just trying to find the similarity of triangles. Otherwise, you cannot solve the problem. Okay. Now you have to use a 6, right? Not 6 is not only just yeah. Let's write down all the possible similarity. Okay. I'm going to put A. We don't know this. We're trying to find all the possible numbers here. Okay. So look at this, right? A and B. Okay. So 1 plus A plus B plus 2 is going to be 6. That's clear, right? Yes. Then those two triangles are similar. Those two triangles are similar, right? You put the ratios, the corresponding ratio, right? So B over 2, right? Compare with this, and it's going to be X over 3. Okay, right? by the similarity triangle. And the other side, you also see that this is 3, right? These two triangles are similar, right? These two triangles similar. A over 1 is going to be x over 3. Okay? So, yeah, the correlation. So once you write all the possible identities, then you will see that how many equations you're going to get. You're going to get 3 equations now, 3 unknowns. So you can completely determine A, B, C, and X. Okay? So this is a, yeah. So then, yeah, this is pretty standard way to do, label all the unknowns, X, A, B, and X, right? And then you find the similarity triangles. Okay, then you look at this, right? Clearly from here, I think A is going to be half of the B, right? This is A is going to be half of the B. Okay, B is longer, or B is double of that. Then you plug into the first equation. You can determine A, you can determine B, right? So A plus B, let's say B is going to be 2A. So I'm going to put 2A as 1 plus A plus 2A plus 2 equals B. And clearly 3A equals 3. So A is going to be 1. So once A is going to 1, B is going to be 2. Okay? So once again B equals 2, then you can also get X, right? X is going to be 3. Okay? Right? Yeah, B is 2, X is going to be 3. Then you can get everything, right? H is going to be 3 plus 3 is 6. So you have a height, and then not only find the area, you determine all the other sides. Right? So they're very important. You have to draw the one line from top to the end. This maybe not the best way, maybe there's a shortcut quick, but we get all the information you need. Right? Then, and yeah. So if you name the 3 variables, then you have to try and do your best to write down 3 equations. Otherwise, you're not able to determine it. You're not able to determine it. Okay. Here we use the similarity triangles. Similarity triangles. Let me try another one. The similarity triangles. Right. So this is a circle. Right. And a random. I draw 2 lines. Okay. This could be something like that. So here's A and the B and the C and the D. And this point P. Right? I know AP is going to be 3, PD is going to be 2, and this is going to be BC is, yeah, AP is going to be 3, and the DP is going to be 2. Okay, PC is going to be 4. Find the BP. Okay, this one X. Right? It's not going to be 5. Something say, okay, 2, 3, 4, 5. No, it's not 5. So the key point is to use the similarity triangles. But also we need the following factor. If I have a circle, okay, then this is alpha, the center. So it doesn't matter where you're going to choose, as long as these 2 points are fixed. This is beta, and this will be the same beta. Okay, beta is going to be half of alpha. As long as A and B are fixed, they have the same open. This is the important fact. The angle, yeah. So when you move the point around the circle, you're not going to change the angle, beta. Okay, as long as A, B are fixed. Okay. Yeah. So in other words, was A, B fixed? Okay. The angle beta is independent of P, the location of the point P. All right. So given a geometry problem, as you see that, you should always draw addition lines to form some triangles, right? Then you may be able to apply Pythagorean theory, or if you see a large triangle, otherwise look for similar triangles. So draw these two lines, connect important points. Maybe you want to draw these two lines, but it's not very useful, okay? So those are the common lines. I think I just need those two triangles. This pair of triangles are similar, are going to be, they are similar. Okay, how do you see that? Why they're similar? Okay, the triangle ABP is similar to the triangle DPC. Okay, so B corresponding to C, D corresponds to A. Why? And look at this. Okay, this is alpha, same angle. Okay, but the angle at the A and at the D also same. Why? Because B, they share the same 2 foot points, right? Yeah. So B and the C, the same B and C there. So that's the reason you get the two triangles with the corresponding angles are equal. So that's what's similar. Once they're similar, then you can write down the expression, okay? There's a ratio, okay? So the left side over the right hand side is 3 over 2 should be equal to x over 4, okay? Compare the ratio of the corresponding side must be equal, okay? Then x is going to be 3 over 2 times 4, it's 6, okay? This is a place where we use a similarity. There was another problem user see. Yeah, let's. I'm going to do other problems. Okay, let's see. Before I move on to the other geometry problems, let's finish this one. So we are given, yeah, here x plus 4 for the square root of x plus 43 is m, and x plus 16 is n. Here where m and x are positive integers. Okay, and find all of them. Okay, find the x, m, n. You cannot guess and try. It takes time. So first of all, you have 3 equations only, but how many unknowns? 3 unknowns. But there's a hidden equation, which is not a real equation, but it's positive integers. This property must be used. Okay. So you actually almost you have 3 equations. You should be able to determine the values. Maybe you can get multiples. You get them not a unique solution. Okay. So how do you do that? Well, you don't like radical, so you square it. X plus 43 equals n squared. Then x plus 16 equals n squared. Right? The first thing you have to do is to eliminate one variable, and it's easy to eliminate x. So equation 1 minus equation 2. Right? So you get 43 minus 16 equals m squared minus n squared. Of course, you are not able to uniquely determine m and n, but very close, okay? Because m and n are integers. 43 minus 16. So the answer will be 17. Let's say 17, right? Yeah, 17, 23, 27, so 27. 27 equals this. But when you see m squared minus square, you immediately should factor it. So it's a product of two numbers. Okay, this is two integers, your integers. Okay, 27 can be written as many product integers. Okay, 27 can be 1 times 27, could be 3 times 9, right? And that's it. There are only two possible ways to do that. Why not 3 times 9? Because this m minus n is smaller. M plus n is larger, right? So you always write a smaller factor first. If you write it in this way, smaller factor first, then you only have two possible ways to write. So let's do it, right? So two possible solutions. Okay, and another possible solution will be 3 here, m plus n equals 9. All right, so here, add them together, 2m equals 28, m equals 14, right? Then n should be equals 13. That's the first solution. And here, if you add them together, 2m equals 12, m equals 6, n equals 3. Okay. So looks like you're going to have positive solutions, but you have to go back to the above equation. Okay, you have to go back to the above equation. Now, n squared. Okay, look at the n squared. If the second one, n equals 3, right? Look at these two equations. So x is a positive integers, right? 43 equals m squared. Then x plus 16 equals n squared, right? So is that possible if you plug this here? No, because 16 plus x will be greater than 9 squared. So it's impossible. Okay, and only the right-hand side is possible, you know. Yeah, so only possible solution for x is going to be 13 squared minus 16. 169 minus 16, and that is going to be 153. So x is 153. And it's the same. You can solve from here, you can solve for x. You'll get the same result. No problem. Okay. So when, yes. So this is the sets of solutions for possible solutions on the right hand side, impossible. All right, I'm going to find the geometry problems. All right. First of all, record the sector, okay? If you have angle theta, it's radius, right? The area of this sector, so theta must be in radians. In radians means 90 degrees should be equal to pi over 2, okay? And 60 degrees should be written in the form pi over 3. Okay, pi is going to be 180 degrees corresponding to. Right? Then the area of this sector, I hope you remember, it's theta r squared. Why divide by 2? Because for the complete circle, theta is given 2 pi. So 2 pi divided by 2 is in pi r squared. So this is an important formula. Okay. So my first question is, if you have a square, okay. So I'm going to draw it at a different location because I really needed to draw 2 circles here. So here is unit square. Well, this can be unit square, okay? Unit square. And at this vertex, I draw the circle. Okay, and at that vertex, I draw another circle. So that should be two congruent circles. My question is, what is the area of this region? Intersection part. Okay. Now, to solve this problem, I said that again, there are a couple ways to do. One is you divide this into two parts. So you have two identical set, right? So if you can find the one of them, then you can solve the problem. Okay. So you can forget that part. You just look at this, right? If you are able to find the area of this, and then you multiply by 2, you can get that, right? So radius is going to be what? Right. How do you find the area of this set? This quotient. There's no direct formula. Okay? Okay. Where's my file? It's gone. Hold on. Okay. You got it? No. I think no. Okay. Just use subtraction. Okay. So all you have to do is the area of this is going to be the sect minus this triangle, right? Okay, that's it. Okay, the sect, yeah. So the area of this this part, okay, is going to be the area of the difference of these two, right? So here is half of angle is pi over 2, right? This is a pi over 2, and radius square minus 1 times 1 divided by 2. Right? So the answer will be pi over 4 is divided by the minus 1/2. Okay. So this is going to be a positive number. Okay. This is going to be a positive number. Okay. Yeah. So why it's positive? You take a 4 out, it's pi minus 2. So pi minus 2 is a positive number. All right. So once you get that, then you can find the area of this two piece. Right? Multiply this out. All right. My next question is. Suppose you have two congruent circles intersect of each other. Okay, then what is the area of this intersection? Okay, we know that they're passing the center of each side. So this is the center. Okay, the radius is going to be 1. Okay, find the area of the intersection. So let me give you some hint first. You just need to find half of that, right? You can draw this. So all you have to do is this is an equilateral triangle inside. So what you have to do is just need to find this portion, right? Yeah, find the area of the shaded region, okay? The reason is if you find that, then you can get, you see, the above picture, you have 4 pieces like that, add them together, and you have a two equilateral triangle. So in order to find the area, just add them together. The sum of the two equal area of two equilateral triangles, and then the 4 small parts. Those 4 small parts are the same. So all you have to do is to find this. Can you do that? Because I already did it above problem. You get ideas. So can you figure out this? Do you still remember the area of the equilateral triangle? All right, so the area of this sector, here's the angle, theta equals pi over 3 because it's an equilateral triangle. So the area of that small piece, let me just draw this, right, is going to be the area of this sect minus the area of this equilateral triangle, right? All right, so how do you find the area of this sect? So that's going to be half of pi over and r squared, okay? Minus square of 3 over 4 times 1 squared, because this is a, if you know the edge length of the equilateral triangle, you can write down the, yeah, you can compute the area quickly using this formula, okay? So remember, if this is A, here's A, here's A, the area is going to be the square of 3 over 4 times A squared, okay? Right? So you simplify a little bit, okay? So you find the area, just the difference. Now, in order to find the area of this sect, you just need to the area of this intersection. Okay, yeah, I'm going to just describe this. The area of this intersection, right? You have 4 pieces, 4 times the area of those pieces, right? And plus 2 times the area of the equilateral triangle, right? And that's it. You know, this is twice of this, right? Four and plus that. Yeah, this is how to simplify this what you get. Okay. All right, so our next problem will be, we're going to make a fence, okay? The fence will be, the only requirement is, this is a fence, it's kind of vegetable garden, put this is the fence, okay? And this is a rectangular garden, the length of each side is an integer. That's important. The length of each side is an integer. Right. Why we have to do that? Because sometimes the fence is built up piece by piece. You cannot bend it one piece. Okay. So each piece could be like 1 feet wide. Okay, 1 foot wide. Right. We know that numerically the length of the fence and the area of the garden are equal. The total length of fencing required in meters, right? And the area of the garden in square meters are set. Okay, what is the greatest possible area of the garden? All right, so the solution is not unique. Okay, so we measure. Let's look at what does that mean. So this is a length n. This is n. Then you have m here, m here, m here. Is the n, right? So the total length is going to be 2n plus 4n. That's total length. This in meter is going to be the area of this garden. It's m times n. So can we figure out the solutions? Yeah. In other words, 2m plus 4m equals nm. Find the largest possible value of the product, which is area. Right? The solution is not unique, but you should have some solutions. All right, how do you do this? Well, we just need to solve for, yeah, you can solve for n or solve for m, okay? So this is let's solve n, okay? So 4n, m minus 4m, okay? You take yeah, let me try to find the n. It's called I'm going to solve for n. The other way around, okay, this nm minus 2n equals 4m. Okay. So you get n minus 2 equals 4m. So clearly, m is going to be this plus m is greater than or equal to 3, right? Because otherwise it's negative, right? Then n equals 4m n minus 2. But this should be the integer. Okay, this should be the integer. All you have to do is to make sure, take a possible value for mn. Okay, so you make a chart. This is the m, this is the n. Okay, so m started from 3, 4, 5, 6, 7. You will stop somewhere. Okay, why when you stop somewhere? When this number, okay, it's going to be, think about that, okay? This number, n equals 4 times m minus 2, okay? First of all, this number is greater than 4, right? Okay, that's the first thing, right? Because the m over n minus 2 is greater than 1. It's larger than that. Okay. But it's going to be close to, it's decreasing, actually, it's decreasing. When decreasing for when m equals 3, right? It's decreasing gradually. Okay, when it's decreasing, it's begin with m equals 3. When m equals 3, it's gonna be 12. Okay, when m equals 4, when m equals 4, it's 4 times 4 here is 2, right? Yeah, that's gonna be 8. Okay, it's decreasing. Okay. But not always you will get the same integer. Okay, what happens when n equals when n equals 5? Let's see, because after that n is getting close to 4, but never reached 4. Let's see when it's going to be. This is going to be when this is going to be less than or equal to 5. Let's see. Okay, it's decreasing. Anyway, decreasing to 4 from 12. This n. All right, so it's going to be 4m less than or equal to 5, n minus 2, and 4m less than or equal to 5m minus 10. So m is going to be greater than or equal to 10. Okay, so I think as the last one you just stop here is 10. You can, if you go beyond that, you will get a number smaller than 5, but never reach to 5. 11 and This is all less than or equal to 5. Okay, and then never be equal to 4, so never be integer. We're looking for m so that you can get an integer. Right, so this is going to be this is not integer, right? 4 times 5 over 3, right? Not the integer. Okay, 6. 4 times 6, and 6 minus 2 is 4. It's good. It's going to be, yes. Okay, then 4 times 7. 7 minus 2 is 5. It's bad, right? Then 4 times 8. And 8 minus 2 is 6. This is not good. 4 times 9. Okay, 9 minus 2 is 7. It's not good. 4 times 10. And the 10, it's going to be 8. Yeah, 10 minus 2 is 8. So this is, it's a 5. Okay? So you will get those numbers, right? Yeah, those are the possible solutions. Okay, this is the possible solutions. And then you do the multiplication, which one gives the larger number. Right? So here you will get m times n, And this is 3 times 12 is 36, right? And 4 times 8, 32. And 6 times 6, 36. 5 times 5, 50, I think. So you can see that 50 is the largest possible area. Okay. Yeah, when you're given when you're given only one equation, assume m and n are integers, then this is the only way you can do. Just solve for one n, then to see when you can get integers. You only can but you can. Why you don't need to consider m greater than 10, because I already mentioned that when m greater, this is a decreasing. When m increases, n decreases, but n is greater than 4. But when this expression, it's in the range, here's 4, here's 5. When there's here, you don't need whatever, there never be integer. Okay, so it's not necessary to keep checking for larger values of m. Stop there at 10. Yes, this actually is a number theory problem. Our next problem, this is a right triangle, A, B, C. Right? And we know that this is going to be 15, that's going to be 9. And that's line bisect of this and the D. Okay. Can we find the length AD? Yeah, please do this problem. Yeah, this is a difficult problem if you haven't seen that before. Okay, you have to use the two angles are equal. All right. Okay, so you have to use this property, the angle to say, okay, are equal. So the idea is draw this line here. Okay, so you will get two triangles. They're congruent. These two are congruent. Got it? Just two congruent. I'm going to find the x, like this is x. Okay. So that means this side is going to be 9. And this side will be what? 15 minus that, it's going to be 6. Okay? So immediately you can determine, where it is located at this point. Okay? And know what? I still don't know at x, right? But I know BC is this right triangle. We have to use that, right? BC is going to be square root of 15 square minus 9 square, right? Which is going to be BC. I think we can, yeah, it's going to be 12. Yeah, it's 12. Okay. You can apply the Pythagorean theory. You can also, this is a, let's use A and B, okay? You can use, yeah, this will be A, right? No, you don't get a similar. So what it can do is, we almost get, right? A plus B is going to be 12. That's the first equation. Second equation, you need 3 equations because there's 3 unknowns, X, A, and B. Okay? So A squared plus 6 squared equals B squared. Another equation is A squared plus 9 squared equals X squared. So now you're able to solve. Now you have 3 equations, 3 unknowns. That this become an algebraic problem. Okay. I think we can get from the first one, get A. If you get A, then you get X squared, right? You want to find X. How do you get A? Well, A squared plus 6 squared equals B squared. But B squared, is going to be 12 minus A squared, okay? Right, by the first equation. So that's 12 squared minus 24A plus A squared, and A squared canceled out. 24A equals 12 squared minus 6 squared. I'm going to simplify it. A is going to be 24, 12 squared minus 6 squared. Can we simplify it quickly, right? So after simplify, it's going to be 9 over 2 here. So what I'm going to do is 6 is going to be, 2 squared times 6 squared minus 6 squared, right? And here's 2, 4 times 6, right? So cancel 6. Right? 18, 3 times 6, and 4. So the answer will be 9 over 2. You can simplify. So it's 9 over 2. So you get A equals 9 over 2, then you get the X squared, right? X squared equals A squared plus 9 squared. So 9 over 2 squared plus 9 squared. Right? So you will take 9 squared out and 1 4 plus 1. Right? Then finally X is just 9 times square root 5 over 2. Then you solve the problem. Okay. Okay, our next problem. Yeah, the next problem is about the infinite sum. Okay, when let's go over this first. So we remember it's 1 plus r squared all the way to the Rn. This is by the formula is 1 minus r to the n plus 1 and the 1 over. Okay, this is identity, you can easily verify. So how to, yeah, we have the following factor, first of all. We find out if the value of I is less than 1, then r to the n's power approaches 0 as n approaches infinity. So when r times r, if I is less than 1, this number product is getting smaller and smaller and smaller, eventually approaches 0. Okay, for example, 1 over 2 to the n is going to be 1, right? And clearly it's going to be 0, right? As n goes to infinity, because 2 to the power n, 2 to the n is getting larger, 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 right? Okay. So using this idea, this is called the limit idea, okay, limit. And how can I add infinite many terms? Okay, so this could be any term, but this goes to infinity. Right? How to define it? The sum of the infinite many terms is defined to be the limit of the finite many terms, the sum of finite many terms. Right? As n approaches infinity. So you get more terms. Right? But this limit can be determined by 1 minus n plus 1 over 1 minus r. So whether this has a limit, just make sure this is going to have a limit. And I know that if I is smaller than 1, this limit is 0. Okay, it's increasing. So we have the following fact. If the absolute value is less than 1, then 1 plus r squared, r cubed, all the way to infinity is going to be 1 over 1 minus r. Okay? Okay, this is infinite many terms, add them together. And just because, this is the numerator approaches 1. And so anyway, just remember, infinite sum is going to be this. Okay? So the good question is 0.9 bar. Okay? 0.9 bar is going to be 0.9999. Right? Infinite many. the infinite many. How do you understand this? This is viewed as 0.9 plus 0.009 plus 0.009 and keep going, right? But each term, I think what's going on here. Where's everybody? It's gone? Okay. All right, let's go back. All right, so we look at this term. So add them together, right? So this is gonna be 9 over 10. It's 9 over 10 squared, 9 over 10 cubed, 9 over 10 to the fourth power. Okay. So I can take 1 over 10 out. So I get 1 plus 1 over 10. 1 over 10 squared, 1 over 10 cubed, and keep it going. So how do you understand the sum of the infinite many terms? Right? This is going to be, I is going to be 1 over 10, right? So this is going to be 1 over 1 minus 1 over I. Right. All right, 1 minus 1 over 10, this is going to be 9 over 10. And that is going to be what? Identical what? So 0.9 bar is nothing but what? 0.9 is nothing but what? Right. My next question is, you have a square, right? You begin with a square. So you have a circle, right, inside. But inside circle, I get another circle. Then I get another circle. Get circle. So you can zone in. So infinite many circles there. This is a unit square. Okay. Find the area, the total area of the circles. Right. The infinite many circles, but total area definitely is smaller than 1 because it's contained in the square. Right? How do you get that? Well, you have to find the formula for the radius, how the radius decays very fast. Right? So look at the picture here. Let's zoom in. I find out this is a square. Then there's another one, right? If this is R and the K, this will be R to the K plus 1. Okay, so I'm going to draw okay. I want to find a relationship between these two radius. This is just a corner, okay? One corner, I zoom in and look at the ice radius, the radius I circle and the ice plus 1 circle. So first of all, this side is going to be square root 2 times RK, right? But this can be sum of RK and RK plus 1. then this portion will be square root 2 RK plus 1. So I get the following formula. And the square root 2 minus 1. And here's square root 2 plus 1. Okay, so the relationship now is clear. RK plus 1 equals square root 2 plus 1, square root 2 minus 1, RK. So it's decreasing, okay, one by one. So the first one, R1 is going to be 1/2. You know why? Because this is going to be R1. R1 is going to be 1/2. Then get R2, R3. So this number, R2 is going to be this number times R1. I try to find the general formula, okay? And keep going. Okay, then R3 equals, okay, because this R2 and R2 equal that. Okay. So you can figure out the general formula, honestly. So R to the K, R to the N is going to be square root 2 over square root 2 plus 1. To the N minus 1, it's going to be 1/2. All right. So to find the area, you have to find the square of this, all those terms. So total, is the total area is R1 square pi and R2 square pi, R3 square pi, and keep going. All right, so that's that common fact. You can take it out. I think R1 is just 1/2. So pi 1/2 square, pi 1/2 square, and for the simplicity, maybe I call it low. Okay. So it's going to be low square. I think this is wait a minute, it's cube. Yeah, this is just the same fact, it's a square. So R cube, yeah, this is a square, right? So just square. So cube square, that's going to be 6. Okay. Then the nth term, and this will be square to the n minus 1. Okay. So so if you take pi of 4 out, you will get low square and square, and the low square and the cube, and low square to the n minus 1, and so on. Okay. So you can find the formula. It's going to be 1 over 1 minus low square. Okay, not the low. Okay, just low square. And then you plug them into what we got here. You see, this is going to be low square is going to be square root 2 minus 1 square root 2 plus 1 square. So this is a sum, okay? You can calculate, that's the total area of the circles. Yeah, be careful, each radius is expressed in the form like that. R1 equals 1/2, R2 equals 1/2 rho, R3 equals 1/2 rho square, and Rn is going to be 1/2 times rho to the n minus 1. Okay. Then you have to square, don't forget, yes, square. So that's why, now let's simplify. What you can get for the rho square? Square root 2 minus square root, right? First of all, you rationalize the denominator, you will get so denominator is just 1. So it's going to be square root 2 minus 2 to the 4th power. Okay, so you can square, you know, you get square, so it's 2 minus 2 square root 2 plus 1, then square. So it's 3 minus 2 square root 2 square, and that is going to be 9 minus okay, so that's what you get. Then the area, I'm very curious about what we can get finally. Yeah, it's going to be pi over 4. Okay. This is a positive number. Okay. So it's going to be pi over 4. And the 12 square root 2 minus 16. All right, so you can simplify a little bit, but this is a positive number. All right, so we studied mainly on the geometry problem today, and next time maybe we'll switch to another topic.